welcome again. We just finished the lecture on this type of data, which is frequency distribution of non-numerical values or categorical data. And all we did was to summarize this type of data in a tabular form and also in a visualization. And the best visualization we used was the pie chart. Now you can see with this kind of data, we cannot tell anything, but when we put it in a tabular form and find the frequency distribution and all these other distributions, it is easier for us to make decisions. And also when we put these values in a pie chart, we can make some decisions. Like we can see Coke has the largest percentage, and the list are Dr. Pepper and Sprite. So knowing this, you can make any business decision. So that's how we can create frequency distribution and this kind of visualization for non-numerical values or for categorical data. So the next thing we're going to do is to look at see what we can do with the numerical data. And we have audit values here. We have just numerical values. And how can we create frequency distribution of the numerical values? So there are some steps which we have to take, different from what we had with the non-numerical values or categorical values. So the first thing here to do is to put these values in the bins. So we're going to decide on the number of bins we are going to create and put all these values and see how many values will go to a particular bin. So first of all, as I said, we have to make decision on how many bins we want to create. The rule is don't select too few bins and too many bins. So looking at this data set, it's better that we have 5 bins and not more than 10 bins. So let's determine the number of bins. So the number of bins here, for me, I'm going to go with 5. I want to create 5 bins and collect these values in a certain way and put in all these 5 bins and see how many values will fall into a particular bin. So let me make this a little bigger. So we have determined this was a decision. I could select 6, 7, 8, 9, or 10 bins. I don't want to go less than 5 bins, and I don't want to go more than 10 bins. Too many bins will not make sense, and too few bins will not make sense. So for me, I think I should go with 5. After we have selected 5 bins, the next decision is to determine the width of the bin. So the width of the bin. So the width of bin will determine how many items should go to a particular bin, and they should not overlap. They should not overlap. So to identify the width of the bin, we need to find the range of this data set and divide it by 5. So here we are going to find, first of all, how do we find range anyways? We can find range by taking the highest or the largest value minus the lowest value. So let's start with the highest value, which is max, and then find minimum value, and then we'll be able to find the range. So how do we get the maximum value? Just put equal sign, type max, and then select all the values in the data set, close the bracket, and enter. Here we have the maximum value, which is actually 13. That is the largest value in our distribution. Let's find the minimum value. Put equal sign, type min. That's the minimum. Oh, sorry. And then we will select the data set, close the bracket, and enter. We'll get the minimum value. So the minimum value from this distribution is actually 12. And now we can find range. Range is the largest value minus the lowest value. So we'll click on 33 minus this 12, with max minus mean. So we have 21. That's our range. To get width, somewhere right here, width is the range divided by the number of bins. Put equal sign, click on the range, divide by 5, enter. So the width here is 4.2, meaning that 4.2 values will be in one bin. But here's the problem. We don't have 4.2 values. We have, if we list them, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to the end. We don't have 1 and 1.2 and 1 point anything of these values. We can count them discretely. So we cannot have 4.2. What should we do is either to mark down, and so we could make it 4. But if we make it 4, then we are left with this 0.2. Where should it be? So we should mark it up, make 5. So the width or the size of the bin should be 5 items will go to each bin. And in fact, here we have, if you can count it, there are 20. We'll count them later. And so if they are 20, 20 divided by 4 will be 5. But anyways, let's make 5 bins. The width will be 5. So if that is the case, then we'll see how we can put all this in 5 bins, all this data in the 5 bins. So the next thing we're going to do here is to determine what will be the lowest value and the highest value of 5 values that should go to either first bin, second, up to 5th bin. So first of all, let's list the number of the bins up to 5. 3, 4, 5. So here we have list of the bins. So now for the first bin, let me highlight this. So for the first bin, what will be our lowest value and the highest value that will go to the bin? So we have to look at the lowest boundary and the upper boundary. And we know that our minimum value is 12 and the maximum value is 13. So our decision, we can take values a little less than 12 and a little more than 33 to make sure that 33 and 12 are contained in one of all these bins, and they should not overlap. So we can make a decision and go down by 2 values less. So if we go with that, that will be 10. We'll start counting from 10 to, so 10, 11, 12, 13, and 14. That makes 5. And so the 5 items that can go to the first bin will start from 10 to 14. So enter. When you enter, you can see that we have 40. We have 14th of October. We'll change this by going here. We have custom. Change that to text. So now we can go back and type 10 to 14 and enter. They will remain the same. Remember, these bins should not overlap. We don't want values that will go to the first bin to also show in the second bin. So in this case, we're going to start from 15, and we'll start counting from 15, 16, 17, 18, 19, 5 values. So that will be 19. And then we'll start from 20 to 24. That will make 5 bins, 5 items. And then without overlapping, we'll start from 25th to 29. And then from 30 to 34. So at least the highest, the maximum value will be within this bin, the 51. So unfortunately, Excel cannot read text values or text because this is text. You can see their text. So let's recreate the bins. And in this case, we're going to take only the upper boundary value or values. So for the first bin, we're going to take 14, meaning that to find the values to go in here, they should be less than 14. They should be from 14 and below. So we're going to take the upper boundary here, which is 19, meaning that values that will go here will start above 14 up to 19. And so for the second one, we have 24 and 29. We just taking the upper boundary, and finally 34. So the next thing is to find the frequency, meaning that we're going to find how many values will go to each particular bin, and that will give us the frequency distribution. So I want you to follow the following. You see, we're going to start with the first bin. So click and hold down, drag down. You see what I'm doing here? Highlight all this. Then leave the mouse, leave as it is. Then click equal sign, type frequency. So we can select frequency. And all we have to do is to select the data array. Don't do anything here. So let's go with the data array, and the data array is our data set. Then put the comma sign. We need to go with the bins array as well. And this is the bin array. So close the bracket, don't enter. Close the bracket, don't enter. So you're going to hold down Control and Shift keys and then click on Return. So I'm going to hold down Control and Shift keys and hit Enter. Remember to do that. So you can see now we could find frequency distribution based on the bins. And so we can find relative frequency. We can also find percentage relative frequency, and we can find cumulative frequency, and also we can find relative cumulative frequency, and finally, we can find the percentage relative cumulative frequency. Exactly the same as we did for the non-numerical values. So let's start with the relative frequency. So remember, to find the relative frequency, we will need to find the total first, the total frequency, and that is put equal sign sum and select the frequencies. I mean the values and enter. So the total is actually 20, as we said before. To get the relative frequency, we put equal sign, take this 4, meaning that 4 items will go to the first bin, and this will be out of 20 values. So we will divide by 20. And remember, each value will divide by 20. So we have to lock down that particular cell, this one here, and we have to put the $sign in between. You don't have to type, you can click F4, you'll get it. So you have to click here, hit F4, and it will put the $sign for you if you're using Windows. For Mac, there are different approaches depending on the type of MacBook you have. Anyways, make it easier, just type $signs for now and enter. And so you can double click, and so you can see we have all the relative frequencies. Here we had, so we can copy, just click here, hold down, drag to the right, and so you can see we have 1, and that's the sum of all this, and that's correct. But now we need to find the percentage relative frequency, and so you can put equal sign, copy these values, enter, and I'm going to double click just to copy these values. And all we have to do is to turn them into percentage, so you can see. And all we can do is just drag down here, and also the same way, just make percentage, so you can see we have 100%. Now for the cumulative frequency, you can remember how did we work in the first video. And so I want you to repeat the same. That it will be your assignment. Do the cumulative frequency, cumulative of these values, and then find the relative cumulative frequency of whatever you have created, and also find the percentage of the relative cumulative frequency on your ROM. And then finally, all you are going to do for this is to create histogram. Histogram is the best visualization that we can use for numerical values. So the frequency of the numerical values. So here is histogram. So there are 2 ways of creating histogram. One is using what we call data analysis. I'm going to share the video to show you what does it mean by the data analysis and how you can use it to do a number of analysis. But today I'm going to teach you just the simple way of creating histogram. So you can see that here we have bins and frequency distribution. And you could also take either bins and relative frequency, or bins and the percentage relative cumulative frequency, all the same. But I'm going to create the histogram based on the bins and frequency. We could actually utilize these bins as well, but for now I'm going to just use this. So After you have selected these values, go to Insert. And you can see we have a number of charts we can use, but I'll go with recommended charts. And I'll select the first one. So here we have frequency, and we don't have any other information. So let me organize this accordingly. So that's what I have created from this frequency distribution. And I want to label this. It's very important to label. And therefore, I will use add chart element. So here, we want to add the axis title, primary and secondary vertical. First of all, we have primary and horizontal here, vertical and horizontal. So first of all, let's go with the chart title, and that should be above this one here. So you can say frequency distribution of ODT data. You can write any topic of your choice, but we need to label the vertical and the horizontal values. So just click here and go to the add chart element and deal with the axis, the primary, which is horizontal, and also the axis title, the primary and secondary, horizontal and vertical. So here you can label this. You see, you can highlight this, and we need to find what values should go on this side. They are frequency, and what values go here. They are the bins. So we have bins and frequency. Make sure that you label your chart. All the charts that you're going to create for this class should be labeled. So here we have columns or bars. So-called bar chart or column chart. It is not histogram. So as I said, I'm going to show you the simple approach, but the other approach will need to know how you can use data analysis. So in this case, I want you to just click on one of the columns. If you double click there, we're going to have this. You go to this side, we have format data point, and the series should not overlap, but we need to fill the gap width. So you can fill the gap width. You can see the gaps are filled. Why? Because we'll start from 10 to 14, and immediately we'll start from 15 to 19, from 19 to 24, 20, 25 to 29. So the gap should be filled, but it doesn't look really nice. So we can change the colors. How do we change the color or the colors? Is you can click on the colors and vary colors by point. So if you can click here, you can see that we have the colors are varied. So you can see we have created a table to explain our numerical data in terms of frequency or frequency distribution. And as I said, when you create frequency distribution like this, our data change from numerical to categorical. So we have the first category, that's for the data from 10 to 14. The second category is the bin that contains values from 15 to 19, and we can count them. They are 4, they are 8, they are 5, they are 2, and they are 1. So we could also explain the data we have by using histogram. And you can see we have a certain shape. And so the question is this normally distributed or other distributions? So if it is other distributions, does it skew to the left? So we can have left skewness, or if they skew to the right, and therefore we can have right skewness. That is something which we'll need to discuss in class. But I'm going to stop here, and then I'll post the last lecture after this.